Hi, everyone, and welcome to Valley of Depth. I'm your host, Mo Islam. My guest today is Austin Link, co-founder of Starfish Space, a company building autonomous satellites capable of rendezvousing with, docking to, and maneuvering other spacecraft in orbit. Before founding Starfish, Austin was an engineer at Blue Origin, where he worked on technologies that would later inform the company's vision for on-orbit servicing. Along with his co-founder, Trevor Bennett, he's now leading one of the most ambitious efforts to make satellite maintenance, life extension, and debris removal routine and affordable. In this conversation, we talk about how Starfish recovered its tumbling spacecraft, Otter, spinning 330 degrees per second, the software and autonomy that makes docking with unprepared satellites possible, the economics of life extension and disposal, and how orbital servicing could reshape both commercial and military operations in space. This and much, much more on today's show. Let's jump in. Austin, welcome to the show.
Mo, it's good to be here. Appreciate you having me.
So tell us a little bit about Starfish's mission. What are you guys doing?
Yeah. So at Starfish Space, broadly, we're building better ways for space infrastructure to be maintained and extended and protected and built upon for the future. And this becomes more and more critical as more and more of the daily services that people have in their lives come from Earth orbit and beyond. What does that translate to specifically at the moment? We're starting off by building a satellite that we call the Otter that is capable of grabbing and moving other satellites in space.
Are those satellites, I'm sure we'll get into this a bit more, are those satellites supposed to be designed for servicing, or are you working around that?
Yeah, so there's a great trick. Anytime you're building a space business or any business, which you go, hey, here's what we want to do. How is it actually useful for anybody? Why is anybody going to want that service? And that's what we really focus on as Starfish, is we've chosen to undertake our journey to improve upon space infrastructure as a business, and therefore we have to provide value. The Otter does that in a couple of different ways. One, we can extend the life of large geostationary satellites. Two, we can dispose of dead satellites. And part of our core thesis is, listen, we can't ask people to attach specific things to their satellite for us to go dock with and then build a business around that in 15 years once they've all attached those things to their satellite. We've got to operate with satellites as they do today. And so that's the focus from the very beginnings of Starfish. And what we're doing with our first Otter missions is we're going up to dock with satellites as they are, with no special features, no fiducials, no docking points, just work with them as they were already launched.
I see. And why do you think now is the right time to build a business around on-orbit satellite servicing?
There's a couple of things that make now a great time to build the business around satellite servicing. And I'd say one of them is because it's now possible, and the other because it's now necessary. Satellite servicing is not a novel concept. It's not a unique thing that we came up with. Humans have been doing satellite servicing since the 1980s. Space Shuttle went up, helped a bunch of telescopes. Northrop Grumman began a life extension mission in 2019, which is awesome, and they deserve a lot of credit for. It hasn't been scaled or widely adopted because, as it's always been done previously, it's just dramatically too expensive. And so as we approached Starfish as a business, we said, okay, well, we have to actually close a business case, not just perform a mission. And to do that, we build on a couple of trends that are existing and exciting in the industry. And one of those is the reduction of launch costs, which SpaceX has really driven. One of those is the shrinking of satellites. And then even trends that are outside of the space industry, like an increase in autonomy and software capabilities and processing capabilities. And we take advantage of all of that and move problems from hardware into the software realm and build a satellite that is dramatically smaller than other satellites to do satellite servicing missions, and allows us to close the business case and provide services that more and more people are wanting as more and more objects are going into space.
So I feel like we're in this era where the iteration between kind of like V1 versus V2 of different spacecraft and satellites and launch vehicles have shortened quite significantly, right? You're seeing upgrades very regularly. I mean, I feel like, just use the SpaceX example. Starlink, V1, V1.5, V2, where V3, they just kind of recently released some specs and design dimensions around that. How do you think about sort of on-orbit servicing in the context of sort of the rapid innovation cycles that we're seeing in space right now versus basically the business case for extending these type of assets versus like how certain companies are designing them to almost not be relevant in a few years because there's going to be like another version?
Yeah. I think satellite servicing, like the whole draw of satellite servicing is to be responsive to things that you learn about in space. That starts with like a life extension mission for a geostationary satellite. When you're designing this really valuable asset that you're anchoring some organization around, and you have to make the decision 20 years ahead of time on what is going to be the right time for the satellite to end its life, that's an incredibly difficult decision that you have huge error bars. We're giving folks the chance to make that decision 2 years ahead of time as opposed to 20 years ahead of time. And that means that you can sit there and go, you know what, this satellite's actually working really well. And the value proposition of this satellite is really high. Therefore, we want extra lifetime. Or you can go, listen, this satellite actually had its communications array fail, so it's not useful anymore. And I'm glad I didn't go design all of this extra life into the satellite that I never got to use. So that responsiveness to new information is fundamentally the core of satellite servicing. And our initial Otter missions directly solve that problem. And as we build on those initial operations, as we build on the ability to operate around and go up to and grab onto other objects, you start thinking about, can we transfer propellant? Can we attach more compute power onto these satellites? Can we replace the batteries or the solar panels or the payloads? And the pace of innovation continues to get faster and faster. And we want to carry that all into satellites in space as we go out to explore the universe. And that's where satellite servicing is essential.
How, let's take a step back. You and your co-founder, Trevor, both came from Blue Origin. Tell us tell us sort of what came together for you guys to decide to want to do this.
It is a tricky decision. You know this, Mo. It's a tricky decision to venture out and start your own company. Both Trevor and I were engineers by background. And I think both of us had the same long-term vision that we were looking towards, which is we want to make an impact on how humans go out into the universe. That's why I went to Blue Origin at the first place. I was excited about the potential for the impact that we could have. After a few years there, we started looking around and seeing a number of folks forming new companies, and not just people that were already wealthy forming new companies, but people that started from just a couple of engineers with an idea, raising capital. I remember looking at early companies like Relativity Space or Analytical Space were some of the companies I looked to at a time to go, hey, you can start from nothing and raise the venture capital and build a business around it and have a huge lever arm to have a big impact. And as an engineer, you got to sit down and do the math and convince yourself you're going to be comfortable from a financial perspective and your family's going to be comfortable from a financial perspective. But the impact that we could make, the way that we could use satellite servicing to transform the pace that people innovate and the way that we develop infrastructure on orbit was a huge opportunity that ultimately we had to jump on.
Yeah. How did you go from sort of the initial concept to to your point, the capital raising environment? How did you go from that initial concept to basically going and convincing early investors that this was feasible and this made sense?
From the very beginning, we were focused on how do we build this as a business, which was kind of funny for two engineers. You could argue we didn't really know what a business was, but we at least understood that we have to have more marginal benefit from each Otter that we build than the marginal cost that it takes to build it. And over time, we learned to fill in the other things of a business, like what the heck is a C corporation, and what is a CRM, and how do you do sales. Eventually, learned, at least to some degree, those things. But we knew that each Otter needed to make money. And so from the very beginning, we had a vehicle design where we were centered around what's the value that we provide to customers and what does it take us to do the mission. And let's make sure that the value that we provide is larger than what it takes to do the mission. And in fact, let's find the optimal point along the way. I think that's easy for folks to lose in the space industry. I think it's easy for folks to say, my customer has come and dictated what they want, and I'm going to respond to every last requirement and check every last box. And all of a sudden you end up with a $100 million satellite instead of a $10 million satellite. And you're struggling to provide, you're not providing more value than what it costs to do it. And so that was from the very beginning with us, what we focused on. And we called a bunch of investors and they told us this is a terrible idea. Why are you starting a space company? And eventually we called a group called Boost VC and they said, this is exciting, man. We're in. Let's go do it.
How much have you raised so far?
To date, we've raised over $50 million as a company, which is both a lot of money and when you're trying to build a bunch of satellites, not a lot of money at the same time.
Yeah, I feel that. Okay, well, let's actually talk a little bit about some of the systems. Walk us through sort of, you've had a couple missions so far. Maybe, actually, why don't we start there? Like, what did you set out to prove and what happened?
We have, so the mission that we have done to date beforehand is a satellite called Otter Pup 2. And Otter Pup 2 is a satellite that we sent up purely as a technology demonstrator for Starfish Space. And there's a long version to the story and there's a short version to the story. The short version of the story is ultimately we got within a kilometer of another satellite on orbit and we took a picture of it. The long version
is much more interesting.
It's a little more harrowing than that. That we went up, we were kicked off of an orbit transfer vehicle, spinning at 330 degrees per second. And that's how Otter Pup and in fact Starfish Space began life on orbit, was spinning nearly a rotation per second, which is 150 times faster than we were ever supposed to spin. It took us months to confirm we'd established contact, get the satellite power positive, eventually get some new software up there to de-tumble the satellite. And we did, and we were successful. And then we had to replan what our entire mission was. And we replanned the mission. And then along the way, the thruster that we'd procured had a component on it that burned out. And we ended up taking the target satellite and flying it to us rather than us flying to it. And that's how we got within a kilometer and took a picture.
What was the propulsion issue because of related to the rotation?
Turned out to be unrelated to the rotation. Turned out to be a design challenge from a couple of years before. And that's one of the things that's really tricky in the space industry is you bring together all of these complex technologies and we try our best to get as much flight heritage as we can on them. But sometimes you get to orbit and they don't behave quite the way you were hoping that they'd behave.
Yeah. Well, so what is, because it's funny. I remember. I mean, you guys got a lot of press about this mission because I felt like the whole industry was like rooting for you guys, and I think there's a small part of that I think had to do with the name Otter Pup. So how did you guys end up naming the? Where did Otter come from? I guess let's start there.
Yeah. Ultimately, Otter, Starfish, gosh, if you dig into the names of our components, it's cetacean, it's cephalopod.
Yeah.
These are probably terrible names, but they're fun. And we're just so lucky to get to work in this industry where we have awesome missions that we're trying to go out and do, and you're trying to push the boundaries of what's capable. And everybody has crap that's going on in their daily life and that gets in the way. And to step back and to dream and wonder about something a lot larger and to try to get to go chase it, gosh, we're so lucky to get to do it. And we try to have fun along the way. And I felt incredibly fortunate as we were announcing what was going on with Otter Pup because we wanted to share and we were planning to share whether mission was fully successful or not successful, what was going on with folks. And as we first shared that the Otter pup was tumbling, we had competitors of ours, like pretty direct competitors, reaching out, sending us papers on de-tumbling satellites and sharing lessons learned from satellite operations that they'd done in the past. Because all of us are really kind of on the same side in the space industry, that it doesn't, obviously it matters to me, and I think Starfish Space is really well positioned to succeed. But like at the end of the day, if it's Northrop Grumman or ClearSpace or Astroscale, and they're doing these awesome missions on orbit, and the Starfish team is, one way or another, just like supporting them to do it, then I'll be glad that these awesome missions are being done on orbit.
How did you guys detumble the satellite? And we've seen this happen before with other missions and satellites and with other companies, and usually it's a disaster, and typically the mission is, the spacecraft is lost. So I'm curious, and also kind of go through sort of some of the emotional components of this. Like, what were you guys thinking at the time? And how did the team come together to kind of solve the problem?
Yeah. So we found this out on day one. We were, it launched like 1 or 2 in the afternoon. We had a big party to celebrate, champagne, cake. Didn't get a lot of news trickling in over the first couple of hours as the OTV was sort of doing its thing. I drove home. On the way home, I got a call saying, hey, there's something going on with the satellite. And so I basically got home, I waved to my wife and said, I got to go back into the office. And I came back in, and there's some number of us in there just trying to figure out what's going on. And we had people like driving around LA to try to find folks in person to give them answers. And we're calling everybody that we know. And we thought, oh crap, it's spinning. We don't know if we got popped off or not. Originally, we thought it was spinning at 30 degrees per second. And then we realized that number had like not been translated from radians degrees. It was actually like 30 radians per second, and that the degrees was just insane. And so the whole picture kind of came to the next day of, boy, our satellite's in trouble. We're not sure if we're going to get contact with it. Even if we do, we don't know what else we can do for the mission. And we just broke it down into the different steps that you can solve, because there's a part of you that is the person who has created the business that goes, wow, this is maybe not great for the business. And there's a part of you that's the project manager that has set up this whole mission to succeed, and now it's immediately gone off the rails. And you're like, oh crap, my mission that I planned. And then there's a part of you that's the engineer that goes, oh, this is very interesting. I wonder if we can get in contact with it. I wonder if we can detumble the satellite. I wonder if we can go nail the timing on our firings of the magnets on board as we're tumbling to push off of Earth's magnetic field little by little and eventually detumble the satellite. And at least for me, the engineering part kind of takes over, and you just go try and solve the problems. And that may not necessarily be the best way to run the business, but at least in that case, it kind of worked out for us.
How did you guys, what was the procedure that ultimately detumbled the satellite?
So it's a controls algorithm, and onboard our satellite, we have reaction wheels, which can point the satellite. Those can handle up to like 2 degrees per second of rotation. So they turn out to be pretty quickly useless once you're spinning 330 degrees per second. So then you have to rely on torque rods, and torque rods are like long cylinders with a bunch of wire wrapped around them, and you send current through it and you generate a little magnetic field, and that interacts with Earth's magnetic field and can push you. And there was an algorithm on board the satellite to use the torque rods to detumble the satellite, and we turned it on, but it was just not ready to handle a satellite rotating at 330 degrees per second. It would have little quarter-second delays here or there, and a quarter-second delay and your satellite has swung 90 degrees, and now all of a sudden your field is doing exactly the opposite of what you want it to do. So what ended up being the real trick is we went to our FlatSat, which is the hardware on the ground, and we ran a bunch of tests to determine, okay, from the moment that we send the command to turn on the current, how does the current flow? When do we see the magnetic field register from the torque rods? What's the exact timing between those different data points? And then fold that into our algorithm and make sure our algorithm is running on the computer that we know the timing of, so that when we do go to turn it on, it fires exactly how it's supposed to fire. And then we had to write the algorithm in a way so that it was a really small amount of data that we had to get up to the satellite. And then we had to kick it off. And Mo, when we hit go, it just like immediately dumped a bunch of momentum out of the satellite. I had a bet with my co-founder. I didn't think it was going to do it. He thought it was going to do it. He was right. I think I owed him lunch after that. And we got so excited. We just kept hitting the button to de-tumble the satellite. We were like, go, keep going, keep de-tumbling. And we accidentally drained our battery as we were doing it. And so we had to like stop and let the satellite recover and let the battery come back up so that we could finish the de-tumbling.
Oh, no, that's amazing. No, it's like, you hate to see those types of issues come up, but they do. And, they happen all the time. So, I'm sure it was a massive learning experience for the team. And kudos to recovering the satellite. The whole mission could have been lost, but kudos to getting it done.
It was awesome. We learned so much in the moment. It allowed us to learn a whole lot afterwards. In a weird way, it was showing that operational capability was a part of what got our initial set of customers, which is SES and the U.S. Space Force and NASA, to go sign on for the first Otters. At the same time, it's not ultimately the goal of our business. We're not building a business to go de-tumble satellites. In fact, I would like to do that not very often. We're building a satellite to grab and move other satellites in space, and that's the goal. And we need to go up there and dock, and that's why Otter Pup 2 is up there right now.
Yeah, so I know you have a few more missions coming next year. Tell us a little bit about what those look like.
Yeah, so the big mission that we're really focused on in the moment is Otter Pup 2. This is a satellite that's up on orbit right now. It's designed to go dock with another satellite. We've been up there for a couple of months, running an initial set of checkout tests and calibration tests and maneuvering ourselves to the vicinity of another satellite. Over the next few months, we're going to be making close approaches and eventually going in to attempt to dock with that satellite. It's purely a demonstration satellite, but it's a huge opportunity for us to learn and a huge opportunity for us to again, share some of the excitement with the outside space industry broadly. That leads into the Otter, which is what we're building our business around in the early stage. And our first 3 Otters, for the ones for the SES, Space Force, and NASA, are all slated to launch in 2026. So we're deep into building those Otters right now, which is, again, really exciting. You sit out and you say, hey, I think I'm going to start a company. And 6 years later, you go, oh my gosh, that's the satellite that we wanted to build. Like, there it is. We're building it. That's a fun freaking moment. Now we got to go make them work.
Now, to ask the kind of stupid question, I assume the Otters are just bigger versions of the pups.
Yes. Yeah. Basically, Otter Pup has enough propellant to dock. Otter has enough propellant to dock and then do something with the satellite that it has docked with.
Got it. Okay. And then where do the, you mentioned it earlier, how do the software systems, I think Cetacean, you said Encephalopod, how do those, I assume, ultimately enable some type of autonomous navigation control?
Yes. So for us, one of the big challenges we have to tackle is, how do you take these 2 satellites that are moving faster than speeding bullets and get them to gently come together and grab onto each other and both continue to operate afterwards? And our software is a key to our ability to do that. It's not a novel concept. Again, satellites were docked in the 1960s. But to date, satellite docking has always required a lot of hardware, a lot of thrusters, a lot of sensors, and that forces you to build a large and expensive satellite. We focus on docking a satellite with just a single camera, with just a single thruster, and our software allows us to do that, but the software is relatively complex to do so. So there's really 2 pieces that we talk about. One is our navigation software. It's called Cetacean, if you really want to spend too much time thinking about marine biology. What Cetacean does is it's figuring out where the other satellite is. So if you are on your phone and you pull up Google Maps and a blue dot appears on the map to say, here's where you are. That's basically what Cetacean is doing. It's deciding where do we put the blue dot on the map. Then there's cephalopod. Cephalopod is what takes that information of where we are and determines, okay, how are we going to fly in and dock with the other satellite? So in your Google Maps analogy, this is what actually provides the directions to the destination that you want to go. Those two pieces allow us to dock a satellite that is much simpler from a software perspective. And that's where our Otter Pup satellite is the size of a microwave, where every other satellite that's done the same thing in history is the size of a car.
Yeah. So you've named them, and I'm curious, and you've publicly talked about what those systems are called. Is that because you are planning to also, and we haven't gotten into business model yet, but is there any element of your business where you're actually selling those systems?
We're ultimately really focused on selling the Otter and the Otter's capabilities as a system. Early on, there are people that will tell you early on, hey, you have this interesting technology. You should sell that as opposed to building the full system. I think that's really a distraction. If you want to have a big impact, then you got to take a big swing, and trying to sell the systems at their earlier stages is just going to take you off course. I'm sure you've thought about this, right? Should we have all of Payload Space or Archaea Media, or should I just, write little guest contributor articles in somebody else's publication? And you could probably be more likely to succeed in doing the latter, but doing the former is how you're going to accomplish the vision that you want to accomplish. And so because of that, we really didn't focus on developing Cetacean and Cephalopod as products unto themselves. We gave them names because it's easier to go organize it mentally. We have now reached a point as a company where there are some times where we're focused on the Otter, but there's another mission that rendezvous and proximity operations could support. We may not be ready yet as a company to go take on that larger other mission, but we can help somebody else do it. And so there are occasionally times where we explore doing that now. We really kind of rejected that idea early in the days of the company, though, to focus on the Otter, and the Otter is still our core focus.
Got it. Okay. And then as far as the business model for the Otters go, is it like a per mission service, or is it like an on-demand space tag? I know that how you're selling it today might be different in the future. So maybe talk a little bit about what the ultimate business model around looks like.
Yeah. Ultimately for us, we want to provide a service here. So we maintain ownership of the Otter, and we charge folks for the services that we provide to them. And that could be on a per disposal basis or on a yearly basis for life extension. There's a lot of ways to frame that service. For the initial Otters, as we are ramping up the initial production and deciding what time for the demand, what's like the right time and the right demand signals, it tends to be that one Otter gets dedicated to one customer. We still own the Otter as Starfish Space, but there's a little more like, okay, well, we're going to build this Otter to go do this mission for so-and-so.
And what are the primary, you've mentioned a few of your customers, which sound like, they're very much lean government, but what are your primary customers? Who are your primary customers today, and how does that kind of commercial government split look?
Yeah, we have customers on both sides. I think if anything, the commercial market is actually a little bit larger for us than the government market. Basically, our customers are anybody that operates satellites. And if your satellite is in geostationary orbit, then the more likely mission that folks will be interested in is life extension, to be able to continue to operate that satellite for a few years. And that works for commercial geostationary satellites, and that also works for government geostationary satellites. And then in low Earth orbit, more likely the mission that folks are going to be interested in is constellation disposal as a service. And that works if you have commercial satellites, or that works if you have government satellites. There are also, especially stemming from our rendezvous proximity operations and docking technologies, there's a few missions that are unique to the government that we can support very directly with the Otter or with some extensions upon the Otter. And those ones are not as commercial, but on the whole still ends up being a very even split for us. And I think you see that with our early customers, that there's SES on the commercial side and they're in GEO, and then there's the Space Force on the government side and that's going to GEO, and then there's NASA on the government side and that's going to LEO.
So from a customer's perspective, how do you help them wrap their head around ROI? Like, how do you help them price that value?
Yeah, that's the key question. Why do people do this? Why would you bother to sign up for this service? On the life extension side, the ROI calculations there are sometimes relatively straightforward. You look at the satellite, you say, here's the revenue that I'm generating per year with this satellite. And then you look at the cost of the mission and you say, here's how much it's going to cost me to extend the life of the satellite. And then you have some amount of operations cost to keep the satellite going, although that tends to be pretty small. And if you're making more money than what it costs you to do the mission, you have a positive ROI for your investment to do the life extension mission. And so, great, it makes sense. On the disposal side, it's sometimes a little bit of a complex picture, but it's fundamentally the same picture. It's fundamentally, hey, my options are, maybe I have three options here. One option is to dispose of all of my satellites at the first sign of any trouble. And then you're really limiting the early lifetime of your satellites, or limited to just the early lifetime of your satellites, and you get a lot less return for your investment in your constellation. One option would be to not dispose of your satellites and then just accept all of the risks of collisions, and ultimately you're at huge risk for tearing your billions of dollars of infrastructure up from the inside out. And then we provide the third option, which is, hey, you can take a chance with your satellites. You can operate them and push their lifetime and get as much value out of the constellation as possible. And some portion of them are going to fail early. And that's where we come in, and we can come and clean them up. And then you both get the extended lifetime from them, and you don't get the increased risk for your constellation from collisions and clouds of debris and all the bad things that can happen up there. And so really we're a risk mitigation service in low Earth orbit, and that turns out in many cases to be a positive ROI for our customers.
Do you think that, sort of a rhetorical question, but do you think that if the powers that be in Congress ultimately pass some type of regulation that requires companies to deorbit their satellites, especially the ones that aren't working, that obviously should be something that will be a huge tailwind for the business. But curious, like, is that necessary, do you think, in order to build, like, on the deorbit side? Like, is that, do you think regulation is necessary in order to really open up that market? Or do you think it's one of those things that will ultimately self-regulate?
Yeah, I don't think regulation is, from our business perspective, I don't think regulation is a necessary thing to open up that market. The rise of constellations has meant that what was sometimes previously a tragedy, the Commons problem, where if somebody's satellite dies, it's just pain to somebody else, is actually sometimes less true now, because in a constellation, you have all the satellites in that orbit. So when your satellite dies, or when you create a cloud of debris, you're the one that has to deal with it. That on its own is an incentive structure that allows our business to develop and succeed. From a regulatory perspective, there are times where the regulations can be beneficial to try to avoid tragedy to the commons type problems. But I actually think that some of our competitors are way overemphasizing the regulatory capture here, and are doing so in a way that risks harming the businesses of the people who are our customers and partners. So, for example, Starlink right now is providing tons of awesome value to people on orbit. Earth observation constellations like a Planet or an Umbra or a Black Sky are providing tons of awesome value to people right now. If you were to make a rule that said you 100% have to deorbit your satellite, and if you don't, you'll never get another license, then all of those businesses just kind of go under, because there's not even, like, the Otter doesn't even exist today in a way that can definitely go and dispose of all those satellites. And you'd be really value destructive if you overregulated things. And so There are some ways in which regulation can incentivize good behavior that is beneficial for all operators, and so we get the most value from space. But I definitely don't think it. I think we have to be careful about going too far, and I think the incentive structures exist even already today for folks to want to sign up for our missions, and they have.
Got it. Okay, awesome. How does your approach differ from the Northrop MEV or like an Astroscale?
Yeah. Ultimately, it comes back to the cost. MEV is great. The folks at Northrop have a lot to be proud of to actually accomplish the mission with the mission extension vehicle, but it costs them way more to do that mission than what they're making, even though they're making $65 million to extend the life of a satellite for 5 years, just a single satellite. But they're losing a bunch of money along the way, which is why there's a couple MEVs up there doing awesome missions, but there's not dozens of MEVs up there doing awesome missions. And that's a great pioneer. They have been awesome as a tailwind for us at Starfish. And frankly, I hope that Northrop and Astroscale have success going forward. And sometimes the challenges they've faced have been a headwind for us to try to battle through. So it's good for our business if they were maybe a little more successful than they have been to date. And what sets us apart is, well, we have a business case that actually closes in providing these services, and we can build a big business around it and scale the business around it.
How do you, like, just to kind of throw out some numbers here, like how big do you think the satellite servicing market, how big, what's the revenue attached to that market in your mind today from what we can see?
Yeah, today, both the life extension and the disposal markets are on the order of a couple $2 billion. And then there is a lot more potential that is available for things like space control or on-orbit upgrades or on-orbit assembly. Those are longer timelines. What the Otter is really targeted at is the life extension and the disposal and some of the government missions. And from those, it's billions of dollars markets just on those, which makes the Otter an awesome business unto itself and just a stepping stone towards where we go broadly.
And compared to some of the other companies we've mentioned today, like what would you say is your like key advantage or like unique strength? What is like Starfish or like the Otter's unique strength? Like maybe beyond size, like autonomy, is it cost structure? Is there a capture mechanism? Like what do you think you guys do better than anyone else?
The thing is, it is the size and the cost. And some of our technology is key to enabling that size and cost. And then the engineering to go around it translates into that size and cost, but the size and cost is the key advantage. And I think people lose that and forget that. If you look at the launch vehicle world, Falcon 9 just dominates the launch industry. It's extraordinary. It's dramatically lowered the cost. It's opened up huge possibilities for what people can do as we go into space. Yes, they land the rocket in a way that people haven't landed the rocket before. It's not really what's the core of what sets them apart. They brought down launch by a factor of 5 before they had landed the rocket at all. When I was at Blue Origin, I sat next to the guy that had a patent on landing rockets on a boat for Blue Origin. The G-fold algorithm that did the landing trajectory was like published and people replicated it all the time. So it wasn't like there was some really key, unique technical insight that made Falcon 9 successful and lower price and open up the launch vehicle world. It was that they got something out there in a way that they could build a business around, and then they could scale and iterate and build on the excellence and the data and the processes that they've developed. And now we can see where SpaceX is today, where they translated that all over to Starlink, and that's a bigger business than the Falcon 9. That's amazing. That's huge. It's exciting to now see things like New Glenn launching for Blue Origin and Rocket Lab and the Electron and all the satellite components that they have. And you can start to see other businesses in our industry doing that same leap. It is as great as all the individual components of the technology are. Ultimately, it's not like we have some magical secret software that if somebody else replicates it, they'll be able to do everything that we are doing. It's the mindset to do the mission affordably and close a business case, and the software is a part of that, and our docking hardware is a part of that. And we're going to continue to build on those initial advantages and as we scale up the Otter and beyond for Starfish.
What do we didn't really get into this much, but I do want to make sure we talk about the defense side of things. So what do you think defense organizations envision for orbital servicing? So like life extension, repositioning. What insights have you gotten from the Department of War on servicing?
You get different insights from different people in the U.S. government. And so they will speak much better for themselves than I will. But what I can say here is, one, it is clear that the Otter, as it exists to do the life extension, to do the disposal, and the capabilities that come with that, is immediately very useful, exactly as it exists today for folks in the government and for folks in defense. There are also a variety of other things that people are exploring, and you'll hear people talk about refueling and dynamic space operations and space control. And you can see some of the actions that, say, Russian or Chinese satellites are taking on orbit right now and threatening U.S. assets and the peace and stability that they provide. The other thing that I think is clear from the defense perspective is that they're looking for new perspectives and new businesses on how to move fast and how to innovate. And we're far from the only company that's doing that. There are a lot of awesome companies out there like Stoke Space or an Impulse Space or an Apex Space that are doing great things and getting contracts to do those great things. And you can see the government wanting to figure out how to work with them to bring their capabilities into defense. I think that's great that pushing us all to do better and innovate more and provide better products is ultimately going to be good for our country. How to take all of that and translate it into, here are the clear products where we can help the U.S. and our allies, and do so in a way that we can build a business around. We definitely have the foothold in with the Otter is a great place to start there. But there's a lot that's going to be mapped out still.
Looking out, like, call it a decade, like if orbital servicing becomes routine, like what major changes do you expect to see in the space industry?
Looking out a decade, if orbital services are routine, then we're going to go beyond just the Otter and the life extension of the disposal services. And it will just be a common thing for people to add propellant to their satellite, or to add compute power to their satellite, or to send really large satellites up and clip them together on orbit. People will feel that their satellites are well protected and safe, and that they don't have to worry about Russia coming up and trying to sneak a peek or interfere with their operations. Ultimately, I think that infrastructure on orbit probably has the potential to look a lot like infrastructure here on Earth, where if you build your office and your water heater breaks down in your office, you don't build a new office, you just swap out the water heater. And that allows you to build bigger and more affordable and more responsive infrastructure than what we do today. And I think that's the power of the future of satellite servicing as we go out in the universe.
What how are you guys thinking, or how are you guys on the financing side? I know you've raised you said over 50 million so far. Any upcoming funding rounds? How are you thinking about sort of the next phase of the business from a capital perspective?
Yeah, we've been fortunate at this point to raise a good chunk of capital from some really awesome investors like Shield Capital, Munich Reinsurance Ventures, NFX, Point 72, a lot of great folks. by nature of where we are as a business, there will be a point in the future where we need to fundraise. We're fortunate given our fundraising at this point, and given the revenue that we're already generating from Otter mission contracts, we're in a really good position right now. But in the future, there is definitely more fundraising for us to become the kind of company that we now know we have the potential to become.
And then what is the long-term vision or North Star that kind of drives you and like the rest of the team that gets everyone really excited about the mission?
Ultimately, we want to provide new capabilities for humans as we go out into the universe. And I think for everybody that means a little bit different things. I think everybody has different missions that they get a little bit excited about. And for some people, it's extending the life of satellites or doing disposal. For some people, it's assembling large telescopes that are going to discover life on other planets. For some people, it's supporting new capabilities on orbit, whether it's data centers in space or manufacturing in space, as other awesome companies are bringing those capabilities to bear. Satellite servicing can help underpin all of those. And we have to get an initial foothold with the Otter, but then it's going to help all areas of the industry the same way that launch helps all areas of the industry.
Right. No, it makes a lot of sense. And, we're putting up tens of thousands of satellites now in space, and at the very least, they need to be properly disposed of. I'm not a big believer of this kind of Kessler syndrome concept, although I do think, and mainly that's because I just think we underestimate how big space actually is. But having said that, there's no question we're going to have more conjunction events or potential conjunction events that will cause serious issues and serious concerns, especially as we put military. I mean, we're going to have communication infrastructure that's going to be vital to the things that we do here on Earth. There's going to be military infrastructure. I mean, there's going to be some pretty wildly valuable assets in space.
Yeah, I mean, space is big, and you do have to be careful about overhyping the Kessler syndrome because space is really big. It gets a little smaller when you like to put all your satellites in the same orbit, but even then, it's still pretty big. I think the trick is it's just so valuable for what we're doing from space right now that if it's providing $1 trillion a year worth of value, and you have a 0.1% chance of all of that being torn up from the inside out, then all of a sudden you go, crap, that's $1 billion risk that we have to get rid of. And I think that's part of where there's opportunity for us.
What do you do when you're not building Starfish, excuse me?
I do a lot of basketball. Probably not as well as I would have in the past. But a lot of basketball.
Who's your team?
Okay, here's the trick, Mo. Mo, what's your basketball knowledge track record?
It's pretty good. I've been a longtime Knicks fan, which has been very painful considering my age because I haven't really seen anything magical happen until the last few years. So,
yeah, that's when you know you're a Knicks fan, when being like the number 3 seed is magical.
Hey, it's totally fair. It's totally fair.
Yeah, I'm originally a Bulls fan, and I'm from Iowa, so in the Chicago area. Man, the Derrick Rose, Joakim Noah Bulls, I loved those folks. It hasn't been a good few years. But I like basketball in all frameworks. Back in college, I was a practice player for the Stanford women's basketball team, which was just an awesome experience. And they reached a bunch of Final Fours, and I may have blown it and cost them a national championship, but that's a story for another time.
That's a story. It sounds like a story for another day. Austin, thanks so much for being with us. Really appreciate it. It's great to hear all of this, and can't wait to get you guys back on after a few more Otter missions.
We'll be excited to be on and share the updates. Mo, appreciate you having me on. Appreciate you doing all of this. What you and other folks are doing, sharing the news about the space industry. I mean, we all read Payload Space and listen to podcasts, and it's part of what makes things possible is we hear about other cool companies doing cool things and figure out how to work together. And You may not always get insight into that because I know you're solving a bunch of really hard problems as you run a business, but you provide a great value to all of us. So really appreciate all the work that you're doing.
I appreciate you saying it, Austin. It's feedback like that makes it all worth it. So thanks so much.
Good deal. Thank you.
Okay.
Thanks for having me.
Until next time.